Hi guys, welcome to another video on AS statistics. So today we're going to be looking at correlation, and here's some of the prior knowledge check you should know before proceeding with this chapter. So you can just pause the video and have a look at the answers. And here's the answer. Okay, so now you've got the prior knowledge. Let's continue with this. So you all would have met scatter graphs at some stage. You did this very earlier on in your secondary school. And we know what the correlation, positive correlation means. So as one variable increases, so does the other, and it would look something like this. And negative correlation, as one variable increases, the other decreases, so it would look something like that. So example of positive correlation could be, let's say, the temperature versus number of ice cream sold. So if you're an ice cream man selling ice cream in the summer, you'd expect some sort of correlation between the temperature going up and number of ice cream you're selling. So that could be an example of a positive correlation. A negative correlation, it could be an example of supply and demand. So let's say you've got a lot of supply on the x-axis and not enough demand on the y-axis, then the price will go down. So as I'm making this video, this is 2020, 2nd of April. So the oil price, crude oil, there's a lot of supply in the market now, but not enough demand due to the virus. So the oil price is going down. So as I'm making this video, the current oil price is trading at $23 per barrel. And if you go back a few months, it was trading all the way up to $70, $80 per barrel. So this is an example of a negative correlation. And no correlation will look something like this. So let's just say, our x-axis is representing how much time you spent revising, and the y-axis represents, I don't know, let's just say, you're watching football or something. A number of time you're revising or you're watching football, you don't expect any sort of correlation. Well, actually, there could be. But anyway, I'm out of ideas on this one. You guys could think about one. So let's just take this example here. So this is just a one table. You can split it up because it goes all the way up to A to J. Now, if we plot the distance from the center, so this question is a study to see the population density of people per hectare from the city center, okay, and we're taking some sample areas. So we want to see, as we get closer to the city, is the population density a lot more than as we get away from the city center. So that's what we want to investigate. So one way to do it is plot the graph. So if we do distance versus population density, and we plot the points, we have something look like this. So you can see it's roughly a negative correlation. So which means the further you get away from the city center, the population density decreases. And that makes kind of sense, doesn't it? So if you get away, the further you get away from central London, for example, if you go outside of M25, the population density will tend to decrease. It's more congestion towards the center. So if we have two variables, a relationship, two variables have a causal relationship. Okay, so if a change in y variable causes change in the other, then we'll say this simply has a positive or negative correlation. But you have to be careful. Sometimes the correlation doesn't imply causation. So we have to be very careful with this, because if you're not using scatter diagram properly, you could just prove anything you like, really. So we have to be careful on what is it that we're trying to investigate. So sometimes it might seem like a link, but there might not be any causation for it. And this is an example of for example, chocolate consumption and Nobel laureate per 10 million people on the population. So although you can look at the graph, it looks like a positive correlation. But would there be a causation? I mean, does it mean the more chocolate you eat, you're more likely to win the Nobel Peace Prize? No, it doesn't. So as I'm making this video, there's also another conspiracy theory going around. So this video is for the time when we're going through a pandemic of coronavirus, COVID-19. Some people believe that as the 5G network is going across the UK, people are dying with coronavirus. So some people are making this a correlation. They're saying 5G is having effect on people's health, and they're dying because of the 5G network and not the coronavirus itself. So again, you have to be careful. We always have to look at it from a scientific point of view. If there is a correlation, either way, whether it's positive or negative, you have to see, is that actually causation? So I hope that makes sense. Here's another example. So here we're looking at age at which education or training ends in a certain place, and we're looking at the hourly pay. So first we asked to describe the type of correlation this shows. And we know this is a very weak negative correlation. It's not even negative really, it seems like there's no correlation, but if you were to draw a line of best fit, I suppose it can be a very weak one. And here we ask about this individual. Hideko says that there are data supports the conclusion that more education causes people to earn lower hourly rate. And we need to find, is his conclusion valid? So in this data we could see is very small, and the other thing is he asked his friends, so he's obviously biased. So you could also say that people who left education earlier have had chance to work and have more experience, so that could have increase in their pay. So one type of line of best fit, which is called the least square regression line. So if we have a line of best fit looks something like this, we're going to try to minimize each of the data points away from the line. And the way we're going to do this, let's call each data set, D1, D2, D3, and so on. So we're plotting Y on X. So we're seeing vertically the difference between the line and each of the data points. And this line could take in the form y equal to a plus bx. Essentially, it's the y equal to mx plus c. And the previous A-level, so the old A-level spec, this was quite a big chapter. You had to do quite a lot of work to work out the value of A, work out the value of B, and so on. But it's all been quite watered down now, so there's not much to do in terms of calculation. So let's take an example. So we're looking at from the large data set, wind speed, or W knots, against the maximum daily gust, G. And this is from the last 15 days. So from your new spec, you're expected to know or work through large data set value. Now your teacher would have given you some data sets on spreadsheet for you to have a look. So here's an example on the exam. What they could do, just give you a snippet of this large data set. So now if we draw the scatter graph, it looks something like this. We asked to describe the correlation between the daily mean wind speed versus the daily maximum gust. So why don't you guys pause the video and write down what you think the correlation is. So it's important that when you give this correlation, you don't just simply say there's a positive correlation. You have to give it in context to the question. So you could say something along the line, there is a strong positive correlation between the daily mean wind speed and daily maximum gust. So as the wind speed picks up, so does the gust, or something along that line. So we're given the equation of the regression line, G equal to 7.23 plus 1.82 W. And here we're asked to interpret the value of the gradient of this regression line. So remember guys, gradient is for every 1 unit you're going across, how much you're going vertically. Okay, this is very important. We need to understand about per unit. So in context to this question, we could say for mean wind speed increases by 1 knot, the daily gust increases by 1.82 knots. So do you guys understand this?
Yeah.
Okay, and lastly, we asked to justify the use of linear regression line in this case. Okay, so as the graph suggests a linear relationship between W and G, it makes sense to use a linear regression line. And that's what you simply write in the exam. So if you know, say, a value of independent variable from a bivariate data, it's possible to use a regression line to make prediction. And that's what we're using a regression line for, is to make a prediction. So if we have these sets of data, so we're looking at head circumference, y centimeter, against gestation period, x weeks for a random sample of newborn babies. And if we plot this, we get a data set that looks something like this. And we could work out the regression line. So here we are given the equation of the regression line y on x, which is y equal to 8.91 plus 0.624x. And the question says, use this equation to estimate the head circumference of a baby born after 39 weeks and a baby born after 30 weeks. And we want to comment on reliability of this estimate. So what I'd like you to do, just pause the video and just work out the estimate for the head circumference for each one of these weeks. And then we'll talk about the reliability. Okay, so what you should have got for each one of these values, for the first one, because we're dealing with 39 weeks, okay, we say this is interpolation because it's within the data set. And if it's interpolation, then we say these are reliable. Okay, and the 30 weeks is extrapolation. So any data set that's extrapolated, we say these are unreliable because you're finding or you're predicting something outside of data range. So one way to understand is, let's say you're plotting a graph on the number of weeks versus the height of a plant. You grow a plant. So as I'm recording this video, it's the month of April. I've done a bit of gardening today. So if I do a table on weeks versus the height of my plant, it will give me a positive correlation. And let's say I plotted it for 4 weeks. So I could work out the height, or I could predict the height of my plant, let's say after 13 days or after 27 days, because I just have to simply look at the regression line and just substitute it in. However, if I don't want you to predict what will happen after, let's say, 10 weeks, my answer, it might not be reliable. Quite simply, the plant will stop growing at some stage. So this idea that you're predicting something outside of data range is called extrapolation, because we don't know, how reliable the data will be after that or before that. In this case, we're looking at data set which is less than the least value. So we have to be always careful of extrapolation. So our nurse wants to estimate the gestation period for baby born with a head circumference of 31.6. Explain why the regression equation is not suitable for this estimate. Okay, the circumference of the head is the dependent variable. So you can't use a dependent variable to work out the independent variable. Okay, estimation should be always using independent variable to estimate the dependent variable, not the other way around. So if you go back to my previous example on ice cream man selling ice cream, so number of the temperature versus number of ice cream sold, you can't really use the number of ice cream sold to estimate the temperature. It just doesn't make sense. So we have to be careful how we read off the values. So we always use independent variable to estimate the dependent variable. I hope that's all clear.